All right, guys, so we're going to finish up the review sheet that we started yesterday. Now, the first problem that we're going to look at is number 21, because I feel like we stopped on number 20 yesterday. Now, with 21, since it's all addition, we don't have to worry about sign changes. And since the denominators are already all the same, 3x plus 2, we can go on and add the numerators together. So I have 9x squared plus 6x minus 1 plus 6x plus 5. We're going to add the three numerators together. At this point here, we can combine like terms. So 6x plus 6x is going to be plus 12x. And negative 1 plus 5 is going to be plus 4. So the first thing we need to do is add them together and then combine like terms, which will get us to 9x squared plus 12x plus 4. Now at this point here, we do need to make sure that the numerator, if it does factor, we need to factor it to make sure that if there's something in common on top and bottom, they simplify out. So when we look at this here, since the 4 is positive, our signs are the same and they match the sign of the middle term. So we'll have plus and plus. Now the factors of 9x squared, well, we'll know we'll have x and x. So factors of 9 are 1 and 9 or 3 and 3. So we'll have 3x and 3x. Because we picked 3x and 3x because if we need something to simplify out, well, we need one or both, and in this case both, have 3x. Now the factors of 4 are 1 and 4 or 2 and 2. We'll pick 2 and 2, which will give us a 3x plus 2 on top and bottom. That would simplify. And it does work out if we check the middle term that we would get 12x because 3x times 2 is 6x, 2 times 3x is 6x, and 6x gives us 12x. So it does work out. So these two will cancel, leaving us with just 3x plus 2 because only one of them simplifies on top and bottom, not both. And that's all we have to do for this here. Any other questions on this here? Now, not all of the addition and subtraction problems will start with the denominators being the same. There's some that will have different denominators, like this one here. And before we start trying to get the denominators to be the same, we need to factor them. So looking at the two denominators, x plus 7 is already in factored form. It's as simplified as it gets. Now the x squared plus 5x minus 14 will factor. Now it doesn't have a greatest common factor, so there's nothing we can pull out of all three terms. So we can use our two sets of parentheses with 3 spaces. Since the 14 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Our factors of x squared are x and x. Now the factors of 14 are 1 and 14 or 2 and 7. We would want 2 and 7, and the 7 would be positive, the 2 would be negative. Now we have it factored, which helps us see what we need to make the denominators be. I'm going to start with the denominator of our rational expression on the right. So what is it missing that the one on the right has? X minus 2. So we're going to multiply top and bottom by x minus 2. So now the one on the right has everything the one on the left has, yes? So let's check it going the other way. What is the one on the left missing that the one on the right has? Nothing. Because we don't have to affect both. Sometimes we're just going to multiply one of them. So the one on the right, or the one on the left, x squared minus 5 over x plus 7 times x minus 2 is going to stay the same. The denominator for the one on the right is now x plus 7 times x minus 2. We don't multiply through the denominators because if it does work out there's something in common on top and bottom, we're going to need the denominator factored. And whenever we add or subtract two fractions, the denominators stay the same, so there's no point in actually multiplying them out because it's not going to change anything. Now the numerators, on the other hand, we will actually have to add or subtract. Subtract in this case, like terms. We'll actually have to combine like terms. So we have to multiply this out. So we'll have to do x times x, which is x squared. X times negative 2 is negative 2x. 3 times x is plus 3x, and 3 times negative 2 is negative 6. Well, first one is still x squared minus 5. The denominator of the second one is still x plus 7 times x minus 2. But the numerator, we do have like terms to simplify. Negative 2x plus 3x is going to be plus x. Any questions on this so far? Now we have both numerators as simplified as they get, no like terms. What that means for us is that we can actually subtract the numerators from each other. And whenever I subtract two numerators, I like to put the parentheses just as a reminder to myself that the negative is not being applied just to the first term, but to all three terms. So really what we have is the first one's still x squared minus 5, but we're subtracting x squared, which makes it negative x squared. We're subtracting the x, which makes it negative x, and we're subtracting the negative 6, which makes it positive 6. Now the last thing we need to do is combine like terms. X squared minus x squared is 0. They cancel each other out. Negative x, we don't have any other terms with just a single x or x to the first power, so it just stays negative x. And our last one, negative 5 plus 6 is plus 1. Now, if we look at the numerator, the only greatest common factor we have is negative 1. But really, all that's going to do is change the signs from x going from negative to positive, and the positive 1 going from positive to negative. But that won't match up with anything in the denominator. So this here is as simplified as it gets. Because the only other way that we could write this is negative x minus 1 over x plus 7 times x minus 2, but even factoring that negative 1 out doesn't give us anything in common on top and bottom to simplify, so it's the exact same thing. Any questions over any of these here? If we have time to come back to 23, we can come back to it later. What I want to look at next is least common multiple. What is the first expression that we can turn both of them into? Now, if we look at 26, 2x squared, it's a monomial term. It's by itself. That's as simplified as it gets. Now, the other expression, 4x plus 12, there's a greatest common factor of 4 that we can factor out. Let's focus up here. Now, it is simplified. So we're looking for least common multiple. We're looking for the first expression we can turn both of them into. Now, since one of them has an x plus 3, we know that both of them are going to need it for them to be the same. Really, with any parentheses, we can take all of them from one and see if we need to add any others from the other one. Since this has an x plus 3, they're both going to need it. Since the 2x squared has an x squared, we know both of them will need an x squared. Now the only other thing we need to figure out is the 2 and 4. So we're looking for what is the first number that I can turn both 2 and 4 into, and that would be 4, because we always go up with least common multiple. So the least common multiple for this here is 4x squared times x plus 3. That's it. Any questions on any of this here? Let's look at number 28. We can come back to it here in a minute. Now at 28, x plus 7 is already factored, guys. Guys, up here. Thank you. X plus 7 is already factored. Now the x squared minus 2x minus 63, we need to factor it. There is not a greatest common factor to factor out, so we don't have to worry about it. So we'll do 2 sets of parentheses. Since the 63 is negative, our signs are opposite. One's positive, one's negative. Factors of x squared are x and x. Now the factors of 63 are 1 and 63, 7 and 9. We'd also have 3 and 21, but I think that's going to be about it. So the ones that we are going to want are 7 and 9, and the 7 would be positive. Least common multiple. So what we could do is take both parentheses from the one we just factored, the x plus 7 and the x minus 9. What does the other one have, the x plus 7 have, that we don't have listed already? Nothing. It's already listed once. The other one only has it once. So this here is the least common multiple. We didn't have to add anything to it. Because x plus 7 in both of them only showed up once, so we only need it once, and we need the x minus 9. That is it. Any questions on this here? We'll look at one more of these here before we move on to solving. Do we want to look at 27 or 29? If we look at 29, we'll need to factor these two here. Now 4x squared minus 16 is, we need to factor it. Is there a greatest common factor between 4x squared and 16? 4. We'll need to factor it out. And if we factor it out, we're left with x squared minus 4. 4 factored out of 4x squared is just going to be x squared. 4 factored out of 16 is 4. Now x squared minus 4 does factor. It is a difference of perfect squares. Because x squared is x and x, 4 is 2 and 2. So it factors all the way down to 4 times x plus 2 times x minus 2. Now if we look at the other one, 6x squared minus 24x plus 24, is there a greatest common factor between these three numbers? 6. And we need to factor it out first. If we factor 6 out of x squared, we're left with x squared. Minus 6 out of 24 is 4. And 6 out of 24 is 4. And lastly, we need to factor the x squared minus 4x plus 4. Since the 4 is positive, our signs are the same, and they match the sign of the middle term, which would be negative and negative. Our factors of x squared are going to be x and x. And the factors of 4 that we want are 2 and 2. Now, there's different ways from this point that we can go about this. But if we look at the parentheses, I can take both of these from one or the other. So I can take the x plus 2 and x minus 2 from the one on the left. Then we can look at the one on the right. What does it have that the one on the left doesn't? another x minus 2. The one on the left has 1. The one on the right has 2. So the least common multiple is going to need 2x minus 2's. The one on the left has 1x plus 2. The one on the right has none, so we need one of those. So that takes care of all the parentheses. Now we need to look at 4 and 12. We need to figure out what is the first number I can turn both 4 and 12 into. Or 4 and 6. Could be 12. I went on and just said the answer. But yeah, 4 and 6, the first number we can turn both of those into is 12. You can look at that in multiple ways. It's just increasing 4 and 6 until we get a number that is the same. And that is it for this here. Any other questions on least common multiple? That brings us to the last type of problems that will be on the test, and that's solving rational equations. Now, when we look at 31, what we want to do first is factor the denominators as far as possible. Here, 2x and x plus 6 are already in simplest form. Then we want to multiply everything by a certain expression so that the fraction will simplify. So one of the things we can multiply everything by is x plus 6. Because the one on the right, the x plus 6 that we multiply it by, and its denominator will simplify out. However, the one on the left, the x plus 6 and 2x won't cancel each other out. So we also need to multiply both sides by 2x, which will make the one on the left denominator simplify out. And then we multiply what's left. So the one on the left is going to be 4 times x plus 6. The one on the right is going to be 5 times 2x. Now at this point here, we need to distribute, then simplify. So on the left, we'll distribute the 4. 4 times x is 4x. 4 times 6 is 24. All right, guys. 5 times 2x is 10x. Now we need to get everything, all the x's on the same side. So the next thing we can do is subtract 4x from both sides. And when we subtract 4x from both sides, we get that 24 is equal to 6x. And last but not least, we would divide both sides by 6, telling us x is equal to 4. And that's it. Now, we don't have to worry about the restrictions for this one here, because if we looked and set the two denominators equal to 0, 2x is equal to 0, we'd see that x cannot be 0, and for x plus 6, it would be negative 6. Because for this problem here, if we got a solution of 0 or negative 6, it would be one of our extraneous solutions, and we would have to exclude it from the answers. And the ones on the test that do have extraneous solutions, there will be a piece in the instructions or for those problems that is saying, hey, look out for extraneous solutions. It will mention it. Otherwise, the problems will not have them. Does that make sense? Okay. Any other questions on this one here so far? We can go on and look at number 32. Now again, the first thing we need to do is make sure the denominators are not factorable. Well, x minus 3 is as simplified as it gets. X squared minus 27, there's a chance it could be a difference of perfect squares because x squared is x and x. Now it's determining what times itself is 27. Is there anything that multiplies by itself to give us 27? Because what we can do is take the square root of 27 and see, do we get an integer? No, we get 3 square root of 3. So, x squared minus 27 is not a difference of perfect squares. So we don't have to factor it. All that means is that, for one, we are going to be multiplying both sides by x minus 3, because the one on the left would simplify with it. But now we also have to multiply both sides by x squared minus 27 is the one on the left. We'll cancel out with it there. Guys. Now what that leaves us with is -1 times x squared minus 27 is equal to x minus 4 times x minus 7. Or we can put negative out front, because negative parentheses x squared minus 27 is the same as saying -1 times x squared minus 27. Either way works the same. Let's keep our heads up, guys. You know. Now the next thing we need to do is distribute. So for the left-hand side, we'll distribute the negative, which would give us negative x squared plus 27. On the right-hand side, we'll have to distribute this out. X times x is going to be x squared. X times -3 is going to be -3x. Then we'll do -4 times x, which is -4x. And lastly, -4 times -3 is going to be plus 12. Now we need to combine like terms. -4x minus 3x is going to be -7x plus 12. Now that we have like terms combined on both sides, we need to get it equal to 0. So one of the first things we can do is add x squared to both sides, which will tell us that 27 is equal to 2x squared minus 7x plus 12. And lastly, we need to subtract 27 from both sides, telling us 0 is equal to 2x squared minus 7x minus 15. Now we could factor this here. We can solve it by graphing. Unfortunately, solving by graphing will only give us one of the two solutions, because most likely the other solution is going to be fractional. Now, since the 15 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Our factors of 2x squared are going to be 2x and x. Now, the factors of 15 are 1 and 15 or 3 and 5. We can do 3 and 5. And again, just to make sure we got the correct factors, we can check this here. So 2x times -5 is -10x. 3 times x is going to be plus 3x, which will give us a middle term of -7x, which is what we wanted. Since we do have the correct factors, and we have two things multiplied together to equal 0, one of them, 2x plus 3 is going to equal 0, or x minus 5 is 0. One of these two is going to be 0. So we'll set them equal to 0 and solve. So for the first one here, we would subtract 3 from both sides, telling us 2x is equal to -3. Then we would divide by 2, telling us x is equal to -3/2. For the other one, we would add 5 to both sides, telling us x is equal to 5. And that is it for this here. Any other questions over this problem here? Any question over anything we've done so far? All right. We're going to look at one more. We're going to look at number 34. Well, 34 and 36. We're going to look at two more. I want to look at this one here because we do have some factoring involved, and 36 is going to involve some restrictions. All right, guys, let's focus in. Now, when we look at this one here, we need to make sure all the denominators are factored as far as possible. The x plus 1 is, the x squared minus 1 is not. X squared minus 1 is a difference of perfect squares. Since it's a difference of perfect squares, x squared is x and x, 1 is 1 and 1. So we get x plus 1 times x minus 1, which will make these nicer to solve, because if we wanted to simplify the denominator out of our middle term, we would need to multiply by x minus 1 and x plus 1. The x minus 1 would cancel with the x minus 1, x plus 1 with the x plus 1. And we have to do it to all three. Now in the first one, the x plus 1 and x plus 1 will cancel. Because x plus 1 only showed up in once in all three spots, or both denominators, we only need to use it once when multiplying. Now we look at all the denominators, they all simplified out completely, so we can see what we have left. In the first one, we're going to have 4x plus 1 times x minus 1 is equal to 12. Times x minus 1. Now, what do we know that x plus 1 times x minus 1 is going to become? Where did we get the x plus 1 and x minus 1 from? So if we multiply them together, they should get back to x squared minus 1. At this point here, if we wanted to write in x squared minus 1 instead of the x plus 1 and x minus 1, that would be perfectly fine too, because that's what we're actually going to get back to. Yeah. Now the one on the left, we're going to need to distribute through. 4x times x is going to be 4x squared. 4x times negative 1 is negative 4x. 1 times x is going to be plus x, and 1 times negative 1 is negative 1. Now, since we know that x plus 1 times x minus 1 are the factors of x squared minus 1, if we want, we can really just rewrite it back as x squared minus 1. Because if we notice that two of the factors, or two things that we're multiplying together, came from something we factored above, we can just replace it. We don't have to multiply it back out. Now, on the left-hand side, we can combine like terms. Negative 4x plus x is going to be negative 3x. Now, we do need to distribute the 3. 3x times x, or 3 times x squared, is 3x squared. 3 times negative 1 is negative 3. Now, we do have like terms. 12 minus 3 is plus 9. Since we do have x squared, we do need to set this equal to 0, so we can subtract 3x squared from both sides. 4x squared minus 3x squared is x squared. And lastly, we can subtract 9, giving us x squared minus 3x minus 10 is equal to 0. Now, since the number in front of x squared is 1, we could graph this. You can plug this into the graphing calculator and see where it crosses the x-axis. Or we can factor it. Since the 10 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared are x and x. Factors of 10 are 1 and 10, or 2 and 5. We would want 2 and 5. The 5 would be negative, the 2 would be positive. And again, since we have two things multiplied together to equal 0, one of them must be 0. And again, we can solve We solve this here. Tells us x is -2. And we also have that x is 5. So our two solutions are -2 and 5. Now the restrictions, if we found them for this here, is that x cannot be 1 or -1. Because with x plus 1, if x is -1, that would give us a denominator of 0. And with x plus 1, if we have -1, -1 plus 1 is 0. So neither one of those would work, but -2 and 5 do. Any questions on any of this here? 0. 36. 0. Let's look at this one here. This is the last one we'll look at on the review sheet. Now this one here is one of the ones that will have restrictions. And when we look for restrictions, we're trying to see what values of x will make the denominator be 0. Now there's 3 spots where it can be 0. X minus 3 and x. So what value of x will make x minus 3 be 0? 3, because 3 minus 3 is 0. And x is indeed 0. So if we get a solution of 0 or 3, it is an extraneous solution and does not work. And again, all we did to find those was set these equal to 0 and solve for the value of x, and those will be our restrictions. Now, looking at this here, what is one thing we know we'll need to multiply through this equation by? X minus 3. We're going to multiply everything by x minus 3. And if we do that, these will cancel out and these will cancel out. Are all the denominators simplified out? No. We'll also need to multiply everything by x, so that the middle one will cancel out. And what that leaves us with is the first one is going to be 2 times x, plus the middle term is 1 times, yeah, because that is going to be 2x. And the x minus 3 is just going to be x minus 3 because we're multiplying it with a positive 1. If it had been minus 1 or minus, then we would need to distribute the negative. But since it's plus, we can just drop the parentheses. And in the last one, we have x times x minus 1. When we distribute, we'll get x squared minus x. So there are some of these steps we can do more than one at once, like rewriting it as 2x or just rewriting it as plus x minus 3. Realistically, if we saw it, we could just have distributed the x and not written x parentheses x minus 1. We could have just written it as x squared minus x. Now, combining like terms, 2x plus x is 3x minus 3 is equal to x squared minus x. Any questions on how we got to this point here? Now we do need to get it to equal to 0, yes? So we will need to subtract 3x from both sides, yes? What else are we going to need to do? At some point we'll need to add 3 to both sides, yes? Now normally we've always shown you this, geometry, algebra 1, as 2 separate steps. It doesn't have to be. We normally show it as 2 steps so that we don't have too much going on at once and you don't confuse terms up. There's nothing against subtracting 3x and adding 3 at the same time. Because we do it at the same time, the entire left side becomes 0. And the right side is x squared. Negative x minus 3x is negative 4x plus 3. There's nothing saying that we can't do that all at once. We normally don't show it all at once because, again, that is a lot going on at one time. So if we had an x squared, we could have moved it over as well. We could have moved all 3 over in one step and done it that way. Now the last thing we need to do is find the solutions for this quadratic equation. Now since x squared is just x squared, we could graph this and see where it crosses the x-axis. If we factor it, since the 3 is positive, our signs are the same and match the sign of the middle term, so negative and negative. Factors of x squared are x and x, and the only factors of 3 are 1 and 3. And if we did check this, it would give us a middle term of negative 4x. Well, what value of x is going to make x minus 1 be 0? And what value of x is going to make x minus 3 be 0? Same exact thing as what we did for restrictions, because they're multiplied together. So we'd set them both equal to 0. X minus 1 is 0. X minus 3 is 0. Solve. Tells us x is 1 and 3, but what do we know? X cannot be 3, because 3 is one of our restrictions, telling us the only value of x that works for this is 1. Any other questions on any of this here? So again, your test is tomorrow. Your test over all of this is tomorrow. So make sure to bring your review sheet tomorrow so that you're ready for the test. Also, if there are any assignments you have not finished or turned in, or both, make sure to get those finished and turned in by the end of the day tomorrow. If you do have any other questions on that, please ask. We can talk about that there.